Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM, problem number 18 from the last exam MLC. You are given the following health sickness model. And the state of being healthy is state 0, state of being sick is state 1, and state of being dead is state 2. You can go from the healthy state to sick state, or from sick state to healthy state, and you can go from healthy state to the dead state and from the sick state to the dead state, but the dead state is absorbing, or you can call it the Roach Motel. Once you go there, you don't come back. For a certain hx, you are given the following information, that the force of transition at hx plus 5 from state 0 to state 2 is the same as the force of transition from state 1 to state 2 at the same age, and it's equal to 0.0020. At t equal to 5, the derivative with respect to t of tpx00 is negative 0.0030, and also at time 5, the derivative with respect to t of tpx01 is 0.0012. Calculate the probability that within 5 years, this person that we're analyzing, this life hx, transitions from state 0 to state 2. And of course, state 2 is absorbing, so once the person gets there, it doesn't come back. So here's the solution. Note that the sum of probabilities of transition out of state 0 to state 0 to state 1 and to state 2 have to add up to 1. And therefore, the derivative with respect to t of tpx02, well, it must be equal to minus the derivative with respect to t of tpx00 minus the derivative with respect to t of tpx01, because these three probabilities add up to 1. If you take the derivative of both sides, you see that, of course, the right-hand side will have the derivative of constant 1 is 0, so the derivatives of these three things have to add up to 0. And that's where we get this second formula, that the derivative with respect to t of tpx02 is the sum of the other two derivatives, but with minus signs. Also, for t equal to 5, we're actually given the values of these derivatives at 5. So at t equal to 5, the derivative with respect to t of tpx02 is is 0.0030, which is minus 0.0030, and then minus 0.0012, and that becomes 0.0018. So we actually know the derivative at 5 of that probability tpx02. And now consider the Kolmogorov-Forward equation for this model. In its matrix form, it is the derivative of tpx, of the transition matrix, is equal to tpx times qx plus t. With that qx plus t is a matrix that has the forces of transition in all non-diagonal entries, and along the diagonal has an entry that is constructed in such a way so that along each row the sum of all entries is 0. So it's basically minus the sum of the remaining of all the forces that show up there. But we are only interested in 5px02, so specifically in the entry in the first row and third column of the matrix. And if we write out the equation, from the entry in the first row and third column of the matrix. Once we write out this matrix equation, you can see that that says that derivative with respect to t of tpx02 is equal to tpx00 times mu02 at time x plus t, because q is at time x plus t, or at age specifically in this case, times tpx01, plus tpx01 times mu x plus t 1, 2. So we consider the specific values for t equal to 5 for everything. The left-hand side, the derivative, is, as we calculated before, 0.0018. The right-hand side, well, it's 5px00 times mu x plus 502, plus 5px01 times mu x plus 512, but these forces are given at that specific time. They're given as 0.002 in both cases, so we just write them out. And this becomes 0.002 times 5px0 plus 5px00 plus 5px01. And of course, that sum is equal to 1 minus 5px02. So if we multiply it out, that becomes 0.002 minus 0.002 times 5px02. And look at this. We were able to get rid of all the other variables in this and only have the unknown 5px02 that we're supposed to calculate. And so this becomes a simple linear equation for 5px02. And you move the 0.002 5px02 to the left-hand side, move 0.0018 to the right-hand side, and then divide both sides by 0.002, and you get that 5p x02 must be equal to 0.002 minus 0.0018 divided by 0.002. And that's exactly 0.1, which is answer B. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.